Hey guys, welcome to another video. In this video, we'll be looking at these three problems under radicals. Okay, so the first question or problem is saying that express this in the form a plus b with the square root of 3, where a plus b are rational numbers. Okay, so let's look at the problem. Let us solve it. Okay, so this is what we have, and as they have said that they want us to express this in a certain format, which I'm going to mention, and then they have also mentioned that a and b are rational numbers. And if you remember on that course that I taught about rational and irrational numbers, I said that rational numbers are numbers that cannot be expressed in form of 1 over 2 or in form of decimal points. Okay, for instance 1.2. So rational numbers are numbers that have common factors. Okay, they have common factors. They can never be left in this format. So meaning that the answer that you're going to get, a and b, shouldn't be in this format. Don't worry, I'm going to show you when to solve it. So now, as you can see here, we have this fraction being added to these two numbers. So on radicals, there is a law that if you have on the denominator part, even if you haven't been taught, they don't tell this in the question, but you have to apply it. You need to know this by heart, because in the future topics, you'll be in most of the scenarios where maybe they tell you maybe to find the value of x, and then the value of x ends up to have a radical on the denominator part. The denominator is this part a. Okay, what I mean by a radical is just like anything that is under a root. Okay, anything. I'm saying a root because it can be a square root, it can be a cube root, it can be a fourth root, it can be any root. Okay, so as long as it is on the denominator, you have to do what is called rationalizing. Now, what is rationalizing? So for you to rationalize, first you have to find the conjugate. Now, again, what is a conjugate? So a conjugate is a number that you obtain after you do some changes to the numbers that we're dealing with. For instance, in our case, let's say we want to find the conjugate of the denominator, right? So you're going to get what you have on the denominator. In our case, we have 3 minus 1 here. So let me just say I'll say conjugate. So I have 3 minus 1 here. Okay, so for me to find this conjugate, so there are two ways of finding a conjugate. Two ways. Okay, and I'll show you the common way, which is usually taught and recommended, and the other way that is rarely used, but you just use the one that you're comfortable with. So the rule is that it's either you change the sign of the radical, then the other one you maintain it, you keep it constant, or you keep the sign of the radical constant, then you change the sign of the other number. Okay, that is in the case where this one here is not a radical. Okay, there are many cases. In a case where maybe let's say on the denominator, maybe let's say you just have 2. You don't have anything like plus what. You don't do any changes. Okay, and then another case, in a case maybe where maybe you have 2 maybe been added to 2. You just change here between the symbol that is in between. Now in a case where one is a radical and one isn't, you either maintain this constant and change this, or you change this sign here and you maintain this constant. Okay, now the standard way, or the commonly used way, or the commonly taught way, is to change the sign of the radical, and that's the one that I'm going to do, that I'll be using. So here you're going to say next 3. I've changed the sign of the radical. Okay, I've put a negative because there was a positive, and here now you say minus 1. Okay, even if you do it the other way, you're still going to get the same answer. So now, by doing this, it means that you have found the conjugate. And if you don't understand, I have a full video lesson on radicals. I've taught everything, starting from the conjugate, the way it is from the basics, including the addition, subtraction, and multiplication of radicals, including the radical equations, all sorts of equations that they bring have been solved. Okay, so in case maybe you want to know this now in depth, because right now I'm just focusing on the concept that are needed to answer the questions that we're dealing with right now. Okay, so after finding a conjugate, now for you to do what is called rationalizing is when now you use the conjugate that you have found, the conjugate of this your denominator, then you multiply it with the top part and the bottom part, or the numerator and the denominator. By doing that, it means that you have rationalized. Okay, so the rationalizing involves first finding the conjugate. Even if you go on complex numbers, it is one and the same. Okay, it's just that there you change the sign of a complex part. I mean the imaginary part, and then you do the same. So if I use the conjugate of the denominator to multiply through the top and the bottom, it means that I have rationalized the denominator. Wow, if I use the conjugate of the upper part A and multiply through the numerator and the denominator, it will mean that I have rationalized the numerator. So they tell you to rationalize the numerator, you do the opposite. So let us proceed. So now I'm going to multiply this with this part. So right now we are first going to focus on this part. It is, again, this is a rule. Let me just say a law. If before you even proceed with any calculation, first rationalize. Even if it was multiplied to a certain number, you first need to first rationalize. Okay, always remember that. As long as you see a radical A, always begin by rationalizing, and I've explained what rationalizing is. So let us solve that. So I'm going to say, so you're going to write plus 1 over minus 1, and then here now you're going to multiply minus 3 minus 1. Okay, sorry, I'll just write that again. Yes, minus, this is 1 here. Okay, and then you conjugate. Now let us multiply. Let's multiply. So here's another thing here. In case maybe where you were just given this and it wasn't being added to another part, or multiplied to another part, we would have just simplified the denominator, and just this one we would have just written it like this. The numerator part would have been just written like this. Okay, you can still be marked. So rationalizing again, let me tell you another let me say a law, because it is always applied. So every time you rationalize, like every time you multiply a denominator with its conjugate or a numerator with its conjugate, when you simplify, you won't remain with a radical. Okay, so in our case A, after I finish rationalizing, after I multiply this with this, A at the denominator, I should not remain with a radical. If I do, it will mean that I have made a mistake. That is a law. Make sure that it is obeyed. That's how you verify your answers. If you see that your final answer, there is still a radical, anything that is under a root, just know that the answer is wrong. Okay? Just know that you've gotten the wrong answers. You need to double check your work. It should be applied, and I'm going to show you how it will be obeyed. So let me begin by multiplying the denominators, then I'll simplify this since we're adding to some numbers there. Okay, so what I'm going to do right now is that I'm going to say this times this, and you need to know that if you multiply a square root with a square root, you're going to get a number that is under the root. That is if they are the same. There's some rules. I think the document in the group, I explained the rules when you're multiplying the radicals. So always know that if you're multiplying a square root with a square root, the square root cancels and the number that is under the root comes back. Okay, so in our case, we're just going to write 3. Now see here, there is a negative 1. So you're going to say negative a. Okay, so you're simply going to have negative 3, and then now you're going to say this times this, you're going to get negative 3, and then now you're going to say negative 1 times this, you're going to get positive. And if you multiply negative 1 times that, you're going to get what? Positive 1, like that. So don't forget the top part. So let us now expand this. Okay, so we're going to multiply this times this. Remember, square root times square root, they cancel. After they cancel, we get what is under the root. And don't forget the sign a, so you put minus a, and then this times this, you get negative 3. Okay, you get the negative 3 there, and then you now go to this number here. You say this times this one, you get negative 3, and then now this times this one, you get 1. I mean 1 times negative 1, that is 1, right? And then now here, so as you can see here on the denominator part, let's simplify. So when you look at how they have come out, here it's like you have 1, and here it's like you have 1. When you're adding the radicals that are having the same numbers under the root, and they are having the same type of roots, you just you just add the numbers that are in front a. So here's like this 1a and this 1a. So 1, since they are like terms, you just focus on the numbers that are in front a. Okay, so here's like you're doing minus negative 1 plus positive 1. That will give you 0, right? So in short, they are going to cancel, and the law has been applied. It should always be applied. So the moment you see that this happens, you should even start celebrating. It means that you haven't made any mistake. So you should even know that you've gotten the answer correct. Okay, so this negative 3 plus 1, here you're going to have negative 2. Okay, let us now simplify the numerator. So the numerator, when you simplify it, I think let's begin with what we have here. So as I've told you, these are like terms and these are like terms. You subtract what is in front. If you don't know the rules when you're adding and subtracting, there is a full lesson in my tutorial group, or even the document that I sent in the free group. I've explained this because it's a topic on its own, and I don't want to make this video lengthy. It will be very long because it also needs like approximately 30 minutes of explanations, okay, and giving you some examples. But for now, just know that if they are the same and they are the same, you add or subtract what is in front. If there was a 2a, it would have been negative 1 minus 2a. So in our case a, there is negative 1 minus 1. That is going to give you what? First, let me write the 3a. Negative 1 minus 1, that is going to give you negative 2. Don't forget what is in common. There's 3, right? Okay, and then you're now going to write the 1 there over negative 2. Okay, so these are not like terms, we can't do anything to them, but this and this are like terms. So if you want, you can first begin by arranging the like terms. So meaning that you're going to have negative 3 minus 1. Okay, these are like, they don't have any radicals, they have something in common, and then these are different, so we're going to put them alone here. Okay, so now here, this is 1 here, so here now in the denominator you're having 2. Okay, so now you're now going to evaluate. So these are like terms. Negative 3 minus 1, you're going to get negative 4. Okay, and then you're going to say minus 2 or 3 there, negative 2. Okay, so after you do this, there is another, I think, let me just call it a rule. In a case where you are rationalizing, where you have the, where you are rationalizing the denominator, you apply the certain concept in mathematics. There's a concept that says that if you have a fraction that is like a plus b, where these are like numbers, over c, you can also write this as, this can also be written as a over c plus b over c. You remember this? Oh, does it make sense? Okay, just know that if you happen to, after you rationalize, then you happen to be in this scenario, you should write in this scenario. Okay, So how do you do that? So here you're going to say neg 4 over neg 2 minus 2 square root of 3 over neg 2. Okay, and then now you simplify. They are going to cancel, right? It enters into 4 twice, right? So you write 2 there, and then they are going to cancel, right? They are going to cancel, right? And then it's like you have 1, but you don't need to write it, so you can just write 3. Okay, so this is what we end up with. So now we haven't done it. Let's look at the question. Now look at the question now. The question is saying that you need to express, after you rationalize this, you now need to add it to this. So we have rationalized. That is how you rationalize. Okay, so now let us add what we've gotten to those two numbers. I think by just reaching A, actually, you even get some marks. Yeah, you even get some marks. So let us solve it. So we're going to say 2 plus the square root of 3. And then we say plus the square root of 3 minus 1. Okay. So now, I think the simplest explanation that I can say is that, first of all, collect the like terms. Okay, so the like terms, these have something in common. They are already arranged. Let's arrange this. So we're going to have 2 minus 1. And you write the radicals. So now, like I said, if you're adding the radicals, you consider this like it's more like you're saying this 1x plus 1x. What do you do? Okay, I think let me just use 2x. 2x plus 2x. It is 4x, right? Same as A. Okay, here it's like you have x plus x. That is 2x, right? That's what you do here. Here you see like they are the same. This is the square root. But if here there was like a 3, a cube root, you don't do anything. I've already explained the rules in my lessons. Okay, the lessons in my tutorial group, but I'll explain what is needed to answer this question. So you need to know this. Very important. Most of the students get confused here, and I don't want you to be among them. Okay, so now you're going to add them. You're going to say this plus this. You focus on what is in front here. It's like 1 plus 1. So here you already have, if you want, you can start from here. Okay, so first I've just decided to begin by evaluating this. Okay, even if you want, you can begin from this side. You're not restricted. Okay, you are free actually. So you're going to have 2 with a 3 there. Okay, and then you're going to have now 2 minus 1. That is 1 plus 2. Okay, if this part is confusing you, what you should be doing is that if you see that these are the same and these are the same, just know, okay, let x be this. Okay, so you replace where there is this with x. You're going to find that here you're going to have x plus x. X plus x, that is what, 2x, right? Now replace back now where there is x with what it is representing. You're going to find that you're going to have 2. In case maybe you're not comfortable with this, your lecturer will still understand. Actually, this is even more professional. It will make you look like you're very intelligent. Okay, because the majority of the students just do this. Okay, so right now we have found the final answer. Now, as you can see, like I said, this is our A, this is our B. Okay, so they are not irrational, they are rational. Why? Because we don't have anything like 1 over 2. There's no way there is anything that is expressed in fractional form or decimal form. We don't have anything like 1.2. We don't have anything. This is what they want. By just doing this, if you see the question, they even say that leave your answer in which format? A plus B. They even included this. So meaning in your final answer, A can be anything, B can be anything, but A is a mandatory. You just need to have a square root of 3. That's what it means. So you even know, they even give you an idea of how your answer should look like. So in case maybe you've screwed up somewhere, then maybe you end up with something else. You just know that I've screwed up here. You double check your work. Okay. So this is how you solve this. Okay. A in our case is 1. B is 2. Now another case A. If here maybe we got a negative, that wouldn't have meant that we haven't left it in this format. Here you can either have positive or negative. Even if in the question they have put a plus, sometimes you'll be ending up with a negative here. It will mean that the answer is still correct. Okay, let's solve another one. So let us solve B. Let's solve B. Okay, so now let us solve this. So they want us to solve for x. Actually, when this question comes, it means that they want us to solve for x. They want you to find the value of x. So oftenly, in fact, like always, when they give you this question, they maybe either say that solve for x or tell you that solve the radical equation. So when you're solving the radical equations, first you need to make sure that you remain with only one square root on one of the side, either the left side or the right side. Now, in our case A, I think the most effective thing is to just remain with this part. Okay, so meaning that we are going to take this on the other side. So the first step, remain with square root on only one side. Okay, so you're going to do this. You're going to say 1. When this goes on the other side, you're going to have positive x minus 1. Okay, so now the rule that says that if you have if you have a square root on one side that is alone, like the way this square root here is, and it is separated by the equal sign, and you do this only if there is an equal sign here. There are some questions where there's maybe the symbols of equality, maybe let's say the less than symbol or the greater than symbol, or maybe this or this. You don't do what I'm doing right now. There are some other additional rules which I'm going to teach. Okay, I'm going to teach this if you have subscribed to my lesson. So, but in the case where there is an equal sign, so you need to be careful before you start doing what I'm about to do right now. You need to check, is there an equal sign? If there's an equal sign and not any of these, you proceed with what I'm doing, because you only do what I'm about to do if there's an equal sign here. So if there is only a square root on one side, what do? You square both sides. Okay, you need to square both sides. So you need, and the reason why you square both sides is to cancel the square root that is on this side. So behind the scenes, a square root can also be written as this is in the root form, and this is in exponential form, where it is written like this. Okay, this representing the number a, and this representing the 2a. A is like the 2. So when you multiply this, or you raise this to the power of 2, what will happen is that the exponent, this one over 2, will multiply with the 2, and then you are going to have 2 over 2, that will be a 1, meaning that you're going to remain with what is inside raised to the power of 1. In short, this one will be cancelled. So that's what happens behind the scenes. So now let us solve it. So you're going to have, so meaning that here, if you raise this to the power of 2, it is going to cancel. You're going to just remain with x plus 4, okay, being equal to, and then here, as you can see, it has been squared. So I'm going to expand. So you're going to expand. You're going to write like this: 1 plus x minus 1, okay, times the same thing, 1 plus. This is actually another way of writing like this. Okay, this and what I'm about to write now is the same. Okay, so right now you're going to have this. Okay, so on the other side you're now going to expand through. And how do you do that? First, you're going to write this side x plus 4. Okay, so you're going to multiply 1 times 1. You're going to have 1 times this, the square root. Now you're going to have the square root itself. So you're going to have x minus 1, and then this times this, you're going to have plus x minus 1. And if you don't know the addition of the radicals, there is a document that I sent in the free group. There is a full lesson in my tutorial group. You can test maybe forward them to you. And then now here, what you're going to do is that here is to multiply with this. So now you're going now to multiply this part with this part. Remember, square root times square root, they cancel, and you get what is under the root. So here you're simply going to get plus x minus 1. Okay, so now let's simplify this part. Let's simplify this part before you come to this part. So here I'm just going to write it the way it is. So I'm going to say x plus 4. So here, these and this are like terms, and negative 1 plus positive 1, they are going to cancel. I'm going to remain with what? The x and the what? And this. Now these two are like terms, okay? Here's like this one, here's like this one. So if they were to be added, meaning that I'm going to have 2 with what is in common, square root of x minus 1, okay? And then I'm going to remain with a positive x here because it hasn't been cancelled. So right now, at the moment, if you want, you can take these on the, I think let me just take them on the other side, okay? So let's just take this on the other side for simplicity purposes. I'm just going to have like a 0a, and a already have x minus 1 plus xa, and then when this goes on this side, it is going to be negative x. When this goes on the other side, it's going to be negative 4. Here there is still 0, so you have 2 the square root of x minus 1, and then here, as you can see, we have x minus x. Here you're going to get 0, okay? Here you're going to, so you just cancel them like this. And what are you going to remain with? With 2, right? You remain with 2. So you have this, you haven't found the value of x, you still have a radical. So right now we've just made one radical disappear from the original question, which is right a, where is it, this one a. So right now we have made this disappear. For us to find the value of x, all the radicals that you have should disappear. So right now only this has disappeared. So again we are going to do the same thing to make even this one disappear, the same thing that we did here. So sometimes maybe they'll give you a question, maybe like this is you have a square root here, and square root here. Just know that you have some work to do. Mean that at first you have a goal of making one disappear, and then the other disappear, and then until the last one also disappear, like the way we have done right now. Okay, so so now let's do the same thing that we did. Remember, there should only be one square root on a certain side. In our case, I think let's just leave it on this side, so that it can be alone on this side. Then the 4a is going to be on the other side. Okay, so we are going to have x minus 1a. Okay, so now at the moment we can simplify this further, since we want to see a square root alone on a certain side. In our case, we had to leave it on this side alone. Now this time let's just leave it on this side, okay? So we want to see it like alone. So since this 2a is divisible into this, you only do that, you only do what I'm about to do if the number that you have a can enter in the number that is a. If it can't, just proceed, okay? So you can divide through by 2. If 2 goes into 4, what are you going to get? You're going to get negative 2, right? If this goes into this is 1, you're going to remain with what? X minus 1. Okay? If here there was like 3, you would have just carried on. Okay, you have just written 3a. So now, as you can see, we now have a square root alone on the other side. What do? You raise both sides to the power of what? You raise both sides to the power of 2. I showed you the reason why they cancel behind the scenes. What that means, because this is like 1 over 2, and when multiply with 2, it will give you the 1, meaning that the one that is under the root is like raised to the power of 1. So now here you have negative 2. Okay, so right now you're going to now square this. So negative 2 raised to the power of 2, the positive cancels, right? Unless there was 3, the positive would have come back. So here it's like you're going to have 4. Okay, here it's like doing negative 2 times negative 2 times you just end a, they cancel, right? In case maybe you're still doubting. So here you're going to have 4, and a the square root is going to disappear. You're just going to remain with x minus 1. And now we are now free to find the value of x. Okay, we can freely now find the value of x. So here you're going to take this on the other side. if you want, you can do the opposite, but it's still going to get the same answers. So you're going to do, you're going to say, for when this one goes on this side, the sign changes, right? Meaning that you're going to have 1, and then here you're going to have x. Okay, so here's the q of 5, and, meaning that your value of x is equal to 5. So as simple as this. Very simple question and interesting. Now, if you're in a mature group, I've solved like I think 4 to 3 different kind of equations that involves these. I mean, radical equations like this. Okay, even the tough ones. I think this is very simple. There's some that are quite involving. So this is how you do it. You just need to understand the concept that you need to have a square root on one side alone, but the reason why we do that is so that it can cancel and make sure that there is an equal sign A. If there is anything like this, there is a topic on function where I'm going to teach this that involves inequalities, radical inequalities. It's another subtopic that confuses a lot of students, and only very few students get the questions correct. So they like bringing the questions on that subtopic, but don't worry, I'm going to teach you. So this is how you do it. Let's look at the next question. So the question is given like this. I think let's quickly solve this one. I've explained everything. So here, as you can see, they are dividing. You need to rationalize the denominator. And how do you do that? You change the sign A. Let's solve this. Okay, so the conjugate. So the conjugate is going to be, here you're going to have a minus, and then you're going to have 5y. Okay, you multiply this with the numerator and the denominator, so you're going to have this. Okay, and then let me just rewrite them again. So you can now multiply with the conjugate. So I mean, here there is a 2. You have an x here minus 5y over 2x minus 5y. Like I said, that here on the numerator, in a case maybe where you're not adding it or multiplying to anything after rationalizing, you can just write like this. Okay, if you want, you don't have to expand it unless maybe you're just interested in doing it or you have a lot of time. Okay, you still be marked. So you're going to say, you're just going to write like this. Okay, and then now here is now where you're going to evaluate. So let us proceed. So you're going to say this times this, same in this number that I'm multiplying, or this expression and this expression, they both have square roots, so this and this are going to cancel. I'm just going to remain with x, but for these twos they are going to multiply. I'm going to have 4, so in simple terms I'm going to have 2 times 2, that will be 4. This times this, square root times square root, they cancel, we get what is under the root. Okay, and then now you're going to say this times this, so now you're going to have you're going to say 2 times neg 5, you're going to get neg 10. Okay, and then this square root, now this time they are not going to cancel, because here you have the y under the root, here you have x under the root. Instead they are going to multiply. That's why I say that there is a full lesson where I've explained these all rules. These rules are very important. If you are struggling to understand radicals, it means that you don't understand the basics. That's why I teach the basics, is because most of the students, I figured out why they get confused by this topic. It's because the way they are taught, or people who teaches them, skips the basics. So the basics are very important. If you don't know the basics, make sure that you go and learn addition, subtraction, multiplication, and division of radicals. Then everything will make sense here. Okay, so you're going to say that I mean, here you're going to say this times this, neg 10, and then now here when you multiply this with this, the roots, since they are different, you're going to have xy. Okay, nothing. They are going to cancel. I mean, they are not going to cancel. And then now you're going to say this times this, this times this. Let's begin with the first one. I'm gonna get positive 10. Okay, this times this. So in short, you multiply the number that is in front with the number that is in front, and the radical with the radical. Okay, that's how it goes. That's the pattern, in case you have observed it. But I recommend you just go and learn the whole basics so that you don't get confused. So you're going to say that this times this, you're going to get xy. Okay, so now here you're going now to multiply this times this. This is 5, so 5 times 5, that will give you negative 25. And then now this times this. Now this time they are the same, right? So you're just going to have ya. Okay, so like I said, that the principle should be observed, or it should be obeyed in a case where you rationalize maybe the numerator or the denominator. So now in our case here, as you can see, we're not gonna have any radical on the denominator, because this and this are going to cancel. Okay, these are like terms, 10 plus negative 10, they're going to cancel, right? So meaning that you're just going to remain with 3xa minus 2y. Then you're going to have x minus 5. You just write it the way it is. So now you're going to remain with 4x minus 25y, and this is your final answer. Okay, but if you want, you can maybe no, in this case I don't think it would be necessary, unless they mention that you leave your answer maybe in a certain format, let's say maybe xy. Okay, then we would have maybe had to first multiply the numerator, and then we do what I showed you, that if it is a plus b over c, then you can write that a over c plus b over c. Okay, so this is how you solve this kind of question. So all you need to know is that first things first, find the conjugate. After finding the conjugate, you multiply with the numerator and the denominator. That's what we did here. We multiply the conjugate, and I said that, but if you want, you can go on and expand here. Okay, but even if you do this, unless maybe you have been taught like to leave it in its simplest form, because rationalizing, they are interested in seeing the magic happen on the denominator, the way it happened. This is what they are interested in seeing. So if you want, you can go on and expand this if you have a lot of time. So this is it for this video, and I hope that you have understood. I know I was maybe in a bit of a rush, but I've tried to explain what I could and what was necessary to be able to answer these three kind of questions. And this is not all about radicals. There are different kind of cases and problems that you need to be familiar with or exposed to. Okay, so make sure that you attempt different questions, and don't forget to subscribe. I'll be dropping some videos like this, but for full lessons where I've taught radicals and everything about radicals, make sure you contact me. I add it to my tutorial group. I have a group where I post video lessons for chemistry, physics, math, and biology. Of course, I try my whole level best to simplify as much as I can. So don't forget to subscribe. I'll be dropping videos like this to help you at least have some clue about some topics, especially radicals. It's a topic that I observed that it is usually taught in a wrong way, and that is why most of the students gets confused by it, the questions under this topic, because they are not taught properly. Most of the people who teach them, or the tutors or the lectures, skip the basics. This topic actually just depends on the basics. The basics are the backbone of every topic, especially in math. Okay, so make sure that you go back to the basics. You understand what is happening behind the hood when I was adding, subtracting, and multiplying. And I hope that you have understood. And have a nice day, and don't forget to subscribe. And if you really like this video, click on the like button. Don't forget to leave a comment. Okay, give your opinion about what you think, or maybe what you haven't understood. I'll be really reply you.